Please begin.
Good morning, everyone, and thank you for joining today's webinar. Today, we have scheduled webinar on applied chemistry and engineering, which has been organized by Applied Science and Humanity Department of Parul Polytechnic Institute of Parul University. The main agenda of this webinar is to get knowledge about how applied chemistry is important in engineering. I, Krupa Pandya, would like to introduce today's guest speaker, Dr. Surbhi Chaudhary. She is Dean Academic at DPG Degree College, Gurugram, Haryana. She is an academician, researcher, and administrator having vast experience. She earned her doctoral degree from Department of Chemistry, Dayalbagh Educational University, Agra. Her research area is hydrogen generation, photoelectrochemical water splitting. She completed her experimental research work in University of Maryland, US. She published her research work in 11 reputed international journals like Springer, Electrochemical Society, etc. She also published few book chapters with recognizable publishers like Springer. She participated and presented her work in various national and international conferences in India as well as in abroad, like an AICHE conference, Pittsburgh, US, and MRS Fall Meeting, Boston, US. She is associated with DPG Group of Colleges since 2013. In this college, the successfully organized various research events like workshop, faculty development program, national seminar, and international conference as well. From past 3 years, she is posted as Dean Academics in DPG Degree College. She successfully deals academic affairs of all courses incorporated under DPG Degree College, Gurugram. We are privileged to see you here, on this platform, ma'am, and listen to you for next 45 minutes. You can start with your session.
Uh, Anyone please respond? Am I audible to you?
Yes, ma'am. Ma'am, your voice is breaking.
Is it okay now?
Yes, ma'am.
I'm start sharing my PPT. I guess my PPT slides are showing to all of you.
Yes,
Anybody,
ma'am.
please give response.
Ma'am.
Okay, this time in this webinar, I'm going to cover the topic about the corrosion. There is a science of corrosion which we meant to study in the chemistry. That is a part of science. So with it, we have certain topics we have to cover in this presentation. First of all, what is corrosion? We will talk about its definition, why we are talking about the corrosion, its various factors which affect the rate of corrosion, the methods of prevention of the corrosion. And if any time left, we will also talk about some types of corrosion. Now, moving forward, what is corrosion? Basically, corrosion is a dangerous and extremely costly problem because the metals which build by the nature by joining together various components and elements together, and they form a metal compound which is used for various purposes, like in the buildings, bridges, pipelines, containers, in the bathrooms, etc. But due to this corrosion, the metal deteriorates. The originality of the metal, the luster, the strength, the tensile strength, extremely damaged and deteriorates. And this makes to leave the quality of the metal to the and leaving it and go back the metal into the nature itself back. So because of the corrosion, building and bridges can collapse, oil pipelines can break, bathrooms flood, and chemical plants leakage occurs. So corroded electrical contacts can cause fires and other problems. Corroded medical implants may lead to the blood poisoning, and air pollution also caused by it. Corrosion also give a vast threat to the radioactive materials. Like radioactive waste materials or radioactive materials are basically stored in the containers, and these containers are basically built up by the metal itself. And for the several years, if we stored radioactive materials in the containers, then the containers also corroded the corrosion by the corrosion process, and because of it, the leakage occurs of the radioactive material. And when the leakage of the radioactive material occurs in the environment, this leakage will affect the surrounding itself and also to the humans, animals, and other biological activities. The most common of the kind of corrosion results from the electrochemical reaction. Basically, corrosion is a process of electrochemical reaction. We can say it is a natural occurring electrochemical cell which build up on the surface of the metal surface. And there is certain reason on the metal surface which acts as a anode, and another act as a cathode. And at the anode, oxidation process occurs, metal converted into metal oxides, and the cathode part got reducted. So the cathode itself doesn't affect by the rate of corrosion. The anode corroded will disintegrate and go back to the nature, and this process continues till the anode exists. And most commonly this problem arises when the metal surface comes in contact with the atmosphere, like in the air gases of all the gases present in the air atmosphere, water, moisture in the form of moisture which is present. General corrosion occurs when most of the atoms of the metal surface are oxidized, damaging the surface of the metal surface. Most of the metals are easily oxidized and lose their electron to the oxygen and in the air or in the water. As oxygen is reduced, That means reduction takes place when gain of electron is there, and it forms an oxide. So metal oxides are formed. Metal oxides with iron, we can say as iron oxide. We can commonly call it as rust. Now moving ahead, we can say in general the definition of corrosion. Corrosion is a process of degradation or disintegration of the metal, thus losing back it to the nature where it was originally formed. Corrosion is one of the most and costly process because metals are expensive, and when they disintegrate, we have to buy another metal to replace them because there is no other solution of it. There is only one solution to protect the metal from the corrosion only. It is basically defined as the natural process. Transformation takes place, pure metal converted into undesirable substance. We do not desire at all that corrosion takes place at all. Corrosion is usually an undesirable phenomena since it negatively affects the properties of tensile strength, the durability of the metal, and the rigidity of the metal, for which we can define as a substance as a metal. All the properties disintegrate because of the corrosion. There is corrosion because due to the effect of the corrosion, rusting takes place. Iron objects become brittle, flaky, and structurally irregular. On the other hand, corrosion is a diffusion control process. We can say that exposed surfaces are meant to prone for the corrosion process, and attempts are made to reduce the activity of the exposed surfaces and increase a material's corrosion resistance. Processes such as passivation, chromate conversion, and other certain methods are there used to protect the corrosion metal from the corrosion. Some corrosion mechanisms are visible, while some others are not predictable. And when the corrosion increased at high rate, thereafter we will get to know about the corrosion of the metal. So in order to reduce the corrosion process, we have to take care of metal time to time, so that in order to maintain the metal. First, I want to move towards corrosion examples. There are certain examples of corrosion that we can say the most common examples of corrosion which we can easily see in the nature. That is, first of all, is the copper corrosion. Copper corrosion is basically this metal is exposed when exposed in the environment. It reacts with the oxygen present in the atmosphere, abundance in the atmosphere. So copper when reacts with the oxygen, it will convert into copper oxide, cuprous oxide. Cuprous oxide is basically red in color. Thereafter, the cuprous oxide also get oxidized and it will convert into cupric oxide, which is black in color. We can see the changes of the chemical component by change in the color, like red converted into black in color. Finally, the copper oxide, cupric oxide, we can say, react with the carbon dioxide, sulfur trioxide, and water, that is the moisture content present in the air. Thereafter, it will convert it into malachite and brockentite, that is copper hydroxide and copper sulfate hydroxide. They are blue and green color in color respectively. So this is the beauty of the copper corrosion. We can see the content changes as the color changes. So copper turnings are basically bluish in green in color because of the formation of malachite and brockentite. Typical example we can see here is the Statue of Liberty. Because of the copper coating over the Statue of Liberty, basically Statue of Liberty is basically made up of cast iron, and above which asbestos coating is there, acts as an insulator. Over that, copper coating is there to protect the cast iron from corrosion. So the copper coating which covered the cast iron over the asbestos sheet, asbestos sheet act as insulator in order to prevent the reaction between cast iron and copper. The copper turnings converted into bluish green in color, and green color of the Statue of Liberty is the corrosion which we can see easily. Then there is another example of corrosion, that is silver tarnishing. Silver tarnishing here acts with the sulfur and its compound. Thereafter it will convert into silver sulfide. Silver sulfide is basically black in color, and due to industrial processes, we can see in the industries there is bulk exposure of hydrogen sulfide in the environment, and in the industrial exposed area, the people who wear silver ornaments, their silver ornaments, due to the form of sulfide, they converted color. Here we can see the reaction. Now we can move ahead with the factors influencing corrosion. The intensity and the rate of corrosion basically depends upon the two factors, that is nature of metal and nature of the environment. Means what kind of metal we are using, what its characteristics, and the secondary is the environment. The metal where it is in the environment, that matters a lot. There are several factors affecting the rate of the corrosion. First, we are talking about the nature of metal. There are certain characteristics which influences the rate and intensity the influence. See students, difference in the rate and in the word. That means rate means the speed of corrosion. How many days, in how many days and how many hours metal corroded, that is the rate of corrosion. And intensity, how deeply the metal corroded from the surface. First, nature of metal. There are various other factors like position in galvanic series, over voltage, relative areas of cathode and anode, purity of the metal, physical state of the metal, nature of surface film, passivity of metal, solubility of corrosion product, and volatility of corrosion product. Now we are taking the points one by one. First is position in the galvanic series. Two metals or alloys are in contact with conducting medium. The more active metal suffers corrosion. See students, there is a galvanic series in which the metals are placed according to their reactivity. Means certain metals are more reactive as compared to other metals, and some less reactive, or there is no reactivity at all, we can say as no. So galvanic series is formed on the basis of reactivity of the metal in it. So in the case of galvanic series, when two metals or comes in contact with each other, the high reactive metal got corrosion more as compared to the less reactive metal. This is the process which takes place as the more reactive metal act as anode in the electrochemical cell of which place at the metal surface, and at anode oxidation takes place, and the metal act as anode, gives electron to the oxygen and converted into metal oxide there. So metal oxide when formed, that means the corrosion takes place. The corrosion takes place, that means disintegration of the metal takes place. This is the ultimate reason why the high reactive metal prone to the corrosion more as compared to the less reactors. Second is over voltage. Over voltage means there is a difference in the if we talk about practically and in theoretically. Practical one, if potential is found to be as compared to the theoretical potential value, the difference is called as over voltage or over potential, and that potential is there accelerate automatically the corrosion rate, because higher potential difference we between two metals or two substances, it will increases the corrosion of. Okay? Move towards the third point, that is the relation of the anode and cathode. Basically, corrosion is increased when anode surface area is smaller and cathode is larger in size. This is because when anode is small, it will give its electron, and those electrons will convert it into metal oxide easily, and disintegration takes place. The reaction more corrosion takes place. But when we take a small anode, the maximum reaction rate, electrons move to, in the small anode, maximum reaction takes place, more electrons from the anode area, and content increases, that makes increase in the corrosion rate. Then if we take small cathode area, the reaction got reversed. Reaction got reversed means reaction of corrosion, like rate of reaction decreases simultaneously, similarly we can say, similarly as of a small anodic area. So here we can see there is an example of a small steel pipe we fitted in a large copper tank. The small steel pipe as an anode and large copper tank at cathode. So we can see easily in the surroundings that if small steel pipe fitted with a large copper tank, the small steel pipe usually corroded within few days. This is because of this reason. The area of anode and cathode directly influence the rate of corrosion. Coming to the next topic, that is purity of metal. More pure the metal, the less corrosion takes place. Because of the presence of impurities in the metal itself created a tiny electrochemical in the metal. Those electrical cell causes corrosion, anodic part corroded. So you can see in the zinc metal there is impurity like lead iron takes, which act as impurity. Chemical cells are localized electrochemical cells are formed. Rate and extent of corrosion increases, and this increases with the more exposure of metal on the surface of metal. So the extent of impurities is proportional to the rate of corrosion. Intensity also there is inversely to the purity of metal. Amount of purity of the metal is, if high, then the intensity of corrosion turned out to be less, because no impurity, then no localized electrochemical cells are formed, then corrosion rate is however low, so thus the intensity. Moving next topic, that is physical state of the metal. We can say physical state like grain size, basically surface area of the, if it is large, the more surface, the more exposure in there, more corrosion rate is there. So the grain size matters. It is directly proportional to the surface area of the metal. The orientation of crystals also matter. The exposure to the atmosphere, however, directly impact on the rate of the corrosion. Also, there is also one other factor, that is a stress. The portion of the metal which comes under stress act as anode. So metal oxide formation on that particular stressed area of the metal is more as compared to the area of the metal which is not under stress. Thus, under stress area, exposure of atmosphere, thus corrosion rate is higher. If grain size is smaller, its solubility is more, hence greater will be its corrosion. Then grain size, basically if a particle is crushed like a metal or any other particle or substance if crushed, then the grain size is smaller. The grain size is small. As the grain size smaller, the surface area is more as compared to the larger area of the particular substance. And if we are talking about the metal, then the grain size is smaller, than its solubility larger will be the surface area, and the solubility is also higher, so greater will be its corrosion. The area under stress, even in the pure metal, tend to be anodic, and corrosion takes place at these areas. I have talked about it. The nature of the surface film. Here, if we talk about the surface film, in the atmosphere where oxygen is present, that means we can talk about the aerated atmosphere. It covered with a thin surface of metal oxide. Means if we generally talk about any metal piece, if kept in the atmosphere, there is a reaction with the oxygen. A small or thin metal layer cover the metal surface. So the specific volume ratio is another term which we talk for the ratio of volume of the metal oxide to the metal, because the exposure lead to the formation of metal oxide over to the metal. So specific volume ratio, if we talk about it, then specific volume ratio, if it is higher, then oxidation corrosion rate, or we can say the rate of corrosion, is found to be less. Means if SVR is inversely proportional to the rate of corrosion. For example, if we talk about the specific volume ratio of nickel, chromium and tungsten, that are found to be 1.6, 2.0 and 3.6 respectively. So here we can see that the corrosion is higher in the nickel than that of chromium. Passivity of metals. Here we can say passivity means less reactivity. Means if metal is the reactiveness of metal is found to be or degraded because of certain reason, because of method of prevention of the corrosion, if we coated its surface by any other substance, then its reactivity decreases. That is called as passivity. In which metal here or alloy formation also, there is another word. Alloy means a combination of metal non-metal. If so that the formation of another substance which we called as alloy, and alloy formation leads to different characteristic to the substance as compared to the metal, in order to increase certain type of characteristics, tensile strength, rigidity, luster, etc. If we want to change it, then we will convert it into alloy. For example, stainless steel. It exhibits a greater corrosion resistance. The resulting film is highly protective but very thin and quite invisible film on surface of the metal or alloy, which is found to be noble. Here we can say and take an example of certain metals which are non-reactive or very less reactive, that are aluminium, chromium, magnesium, nickel, cobalt, etc. They have high corrosion resistance. High corrosion resistance means they are very much less prone to corrosion rate than expected from their position in the galvanic series. This is because of the passivity of metal, which decreases the rate of corrosion rate. Here we can say there is an example like stainless steel. The corrosion rate of corrosion in the stainless steel is less because of the presence of chromium. The chromium metal act as an impurity, and because of its impurity, because of its passivity, the passivity creates decrease in the corrosion rate in the stainless steel. Now coming to the next topic, that is solubility of the corrosion product. In electrochemical corrosion, if corrosion product is soluble in the corrosion medium, then corrosion proceeds at faster rate. Means we can say corrosion takes place because of the electrochemical reaction, and the corrosion product, that is the oxide in the electrolyte solution or at the anode portion. Then if that is soluble in the electrolyte, then the rate of corrosion is high because it will transmit electron, and if there is transmission of electron in the environment or in the liquid medium, that is the electrolyte medium, then the corrosion rate will increase. Similarly, or on the contrary, we can say if the corrosion product is found to be insoluble in the medium, then we can say that corrosion product which is to be insoluble, that makes a barrier to and cover the cathode, so that the rate of corrosion will decrease. It acts as a barrier. For example, if we talk about the corrosion of lead in sulfuric acid, it will decrease because of the formation of lead sulfate. Lead sulfate is not able to dissolve, or we can say insoluble in the sulfuric acid, so that as the formation of lead sulfate increases because of the corrosion, the rate of corrosion itself decrease automatically, as the lead sulfate is insoluble in sulfuric acid, and the corrosion process reaction of the corrosion will degrade itself. Another one is, that is the last point, volatility of corrosion product. If the corrosion product formed is found to be volatile, means the of product and it will disappear from the electrolyte or the reaction medium, then we can say the transmission process or the ionization process increase, so that the rate of increase. For example, if we talk titanium oxide molecule in case of the metal, if we take as corrosion occurs, which is found to be volatile, will increase as when the molybdenum oxide forms. Second part of the corroding environment. There are certain factors which affect again to the corrosion process, that is temperature, humidity of air, presence of impurity, Hello. Am I audible?
Yes, ma'am. Yes, ma'am.
Okay. Somebody said that I am not audible and visible. That's why I asked you in between. Uh, are you able to see my screen? Anybody, please?
Ma'am, your PPT is not visible.
My PPT is visible and my voice is audible or not?
Your PPT is not visible, ma'am.
Not visible. Okay, okay.
Yes. Okay, okay. Now,
Now it's visible now or not?
yes, yes, yes. Done.
Okay.
Yeah, okay.
Now I'm continuing my topic, that is the influence of pH. Last here, now started here from slide only. Generally, the acidic media, that is the medium in which the pH is about to less than 7. The pH criteria is that 7 is the neutral medium and above 7 is the basic medium and below that acidic medium is there. So if we talk about the acidic medium, when the pH is less than 7, we can the medium makes the metal more corrosive as compared to the alkaline and neutral media. The metals are readily attacked by the acids, so corrosion of the metal can be reduced by increase of pH of attacking environment. For example, if we talk about the zinc metal, it rapidly corrodes in the weak acidic solution, and its rate of corrosion decreases when we increase the pH to 11. That means if the medium's pH, if we change to basic one, then the rate of corrosion decreases. Another one is nature of ions present. Some of the ion increase corrosion while others decreases. Means the presence of certain ion increases the rate of corrosion very high as compared to other one which decreases it. The presence of an ions like silicate in the medium leads to formation of insoluble reaction products like silica gel which inhibit further corrosion. If chloride ions, if we talk about it, then it will destroy protective and passive surface film, so the metal exposed to the environment for the other corrosion, so the corrosion of those metals increases when they come in contact with the chloride ions. Presence of ammonia also increases the corrosion of iron. Presence of even traces of the copper in the mine water accelerate the corrosion of iron pipes. So basically in the pipelines which are formed by the iron, if in the water, if there is a traces of copper, they react together and the pipelines, those are made from the iron one, they are corroded. Here we can see, I forgot to explain that pH and corrosion rate. Here we can see that the rate of corrosion increases exponentially when the pH decrease in between 3 to 4. Now the one is conductance of the conducting medium. The conductance of a particular medium, if found out to be higher, then the rate of reaction is also being fast. The conductance of dry sandy soil is lower than those of the mineralized clay soils. Stray currents will cause more damage to the metallic structure buried under clay and mineralized soil than those under dry sandy soil. So this is the one. If conductance of the ions increases in particular medium, then the rate of corrosion increases. Formation of oxygen concentration cell. See, concentration cell are basically formed due to the galvanic corrosion. This is basically the difference in the oxygen concentration over to the metal surface. When there is a oxygen concentration is low, and if at a exposed metal surface found higher concentration of oxygen, then there is certain difference in the oxygen concentration over to the metal surface. Then electrochemical cell is formed, which is called as oxygen concentration cell. Corrosion takes place, and the rate of corrosion depends upon the difference in the oxygen concentration over to the metallic surface. As the percentage of oxygen increases, the rate of corrosion also increases due to the formation of oxygen concentration cell. The decay of metal occurs at anodic part only, and cathodic part is protected here. This is the difference, because the oxidation is only takes place at anode and reduction takes place at cathode. So where oxidation takes place, there only metal oxides are formed and metal degraded. So here we can say both reaction, like here we can say see in the rusting of iron here in this picture. In anodic area, iron is converted into iron ion and electrons are released. In the cathodic area, the electrons are gained by the oxygen and water, and they will converted into ions. Thus, the formation of concentration cell promotes the corrosion, but it occurs where oxygen concentration is low. Means the metal surface which faces low concentration of oxygen acts as anode, and the metal surface which acts exposed to the higher concentration of oxygen act as cathode. So this type of reaction, like electrochemical reaction, takes place, and this electrochemical cell created by the difference in the oxygen concentration is called as oxygen concentration cell. So this is all factors affecting of the rate of corrosion and in the intensity of corrosion. Now we need to talk about certain methods which are used to prevent the corrosion process, because corrosion is the disintegration or degradation process of the metal, which degrade the metal, and so that the metal loses its original characteristics. First, there are particular 5 methods I am talking here about. Barrier coating for the corrosion prevention, hot dip galvanization method. Third one is alloyed steel. We can build in basically in the stainless steel method. Fourth one is Cathodic Protection method. Fifth one is Sacrificial protection method. Now we take all these things one by one. Barrier coating method for the corrosion prevention. Here we talk about when we want to protect a certain metal from the corrosion, we cover that particular metal surface by a barrier coating. In some example, we can see plastic resin covering we kept over the surface of the metal, so that the metal surface do not come in direct contact to the atmosphere, or that barrier coating act as a insulator in between the atmosphere and onto the metal surface, so that the oxidation process doesn't take place and the metal got protected from the corrosion. The barrier coating forms an insulating and physical barrier thus stopping the contact of corrosive elements such as electrolyte with the substrate. Barrier coatings are typically applied on the metals and ceramics when they are unable to withstand very harsh operating condition. Means basically this type of method is basically used in the industrial purpose, where in industries the corrosive gases are there. Harsh temperatures, harsh pressure zones are available, so that the metal surface are more exposed to the corrosion process. In that case only, the barrier coating method is used in order to protect the metal from corrosion. And because of this type of sudden high temperature, flow of harsh corrosive gases, the metal corroded, and sudden, or we can say catastrophic failure takes place in the industries. Catastrophic failure means sudden power failure of the machines during process. In order to prevent this and to enhance the lifetime, or we can say duration of the particular metal and ceramic components, they are protected with a different material that can withstand with these demanding environments. The property of barrier coating materials has to be matched with that of the underlying substrate. So here we can judge the material of barrier coating according to the metal which we have to protect. Barrier coating aims to prohibit water, oxygen and other chemicals from the making contact with the substance. Basically and practically, if we talk about, it's taken for granted that some water and oxygen will reach the surface that barrier coatings protects. But since the water that does make it through a barrier coating is not significantly charged, the fundamental elements necessary for kicking out the process of corrosion that are not all present. So barrier coating is basically a covering or coating in order to make the metal safe from the environment, and that barrier coating acts as an insulator in order to prevent the corrosion. This is the first method. Here we can say the steel is protected by a protection coating. Here we can say this is the anti-corrosion protection coating of the steel. This is just a picture. We can see here there is a lamination or the protective paint coverage is placed over to the surface of the. Second one is hot dip galvanization for corrosion prevention. In this method, certainly hot dip, it is a process of hot dip galvanization, which we generally also called as HDG for corrosion prevention method. It is a process of coating of the iron and steel with zinc. Here, iron or steel alloy we immersed in the molten zinc in order to make zinc alloy covering to protect the iron from corrosion. The alloy is being formed over to the surface of the base metal when immersing the metal on a bath of molten zinc at around 450 degree Celsius temperature. Hot dip galvanization offers coverage both externally and internally. Internally, we can say because of the formation of alloy over the surface of the metal, it will protect and enhance the characteristic of the metal so that its durability and the strength will increase. It self-repairs when damaged, sacrifices itself to protect the base metal. It is environmentally sustainable, has got impact and abrasion resistance. Like other corrosion protection method, galvanization protects steel by acting as a barrier between steel and the atmosphere. This process is very effective in order to form the metallurgically bonded zinc iron alloy layers, not only create a barrier between the steel and environment, but also cathodically protect the steel from the corrosion process. So here I have a limit of time, so I'm moving forward. Here we can say this is the picture of hot dip galvanization method. Here we can see that the stainless steel or the iron rods are being immersed in the molten zinc in this type of container. Here we can see, and now the alloy formation is taken place over the metal surface. Galvanization process is there, and so that the iron or the steel will protect from the environment for further corrosion. Now next is the alloyed steel or the stainless steel method for the corrosion prevention. When other prevention now here we talk about the alloyed steel process. Alloyed steel process means, this method means, when the metal non-metal or non-metal non-metal, when they react together, they form a particular other compound that is called as alloy, which have enhanced characteristics as compared to the metal. And these alloy steels are more safe from the environment as compared to the pure metal. These alloy steel displays various environmental, chemical and physical properties that can vary within the element used here. The proportion of alloying element can provide different properties: resistance to corrosion and staining, low maintenance and luster, make stainless steel an ideal material for many applications where the strength of the steel and corrosion resistance are required. And as compared to metal, stainless steel is more able to roll into the sheets, plates, bars, wires and tubing also. Alloying can affect microstructure, and heat treatment and mechanical conditions are also improved as compared to the metals. Alloy steels are made by the combining carbon steel with one or several alloying elements such as manganese, silicon, nickel, titanium, copper, chromium and aluminium. These are specific properties which enhance in the alloy steel. This is the alloyed steel which prepared by the particular elements in presence of particular elements in the different proportion in order to make it corrosion resistance. Now the fourth method is the cathodic protection. Cathodic protection method is basically are of two types, that is galvanic method, protection method, and second is the impressed current cathodic protection method. These two type method there is certain differences there, and the galvanic method is somewhat similar to the next method, that is sacrificial protection method for the corrosion prevention. Here we can see galvanic protection consists of applying a protective zinc coating to the steel to prevent rusting. The zinc corrodes in place of the encapsulated steel. Here basically here we if we want to protect a particular metal, then more reactive metal is taken as an anode here in order to protect the metal from corrosion. This is the basic concept of this cathodic protection method. More protective, in order to protect the metal which we want to protect, is taken as cathode in the electrochemical cell, and we insert a more reactive metal which act automatically as the anode. These systems have limited lifespans, as the sacrificial anode protecting the underlying metal will continue to degrade over time until the sacrificial anode is no longer capable of supplying protection. Impressed current, if we talk about the second one, that is the impressed current cathodic protection system. It consists of anodes that are connected to a power source that provides a perpetual source of electric flow. The sacrificial anode method protection uses a more active metal than the base metal to sacrifice ions. So sacrificial anode have stronger electrochemical potential. This method much longer protection give than a sacrificial anode, as anode is supplied by an unlimited power source. So this is the cathode protection method. This is a picture how we protect cathode. And this one is the last method, that is the sacrificial protection method for the corrosion resistance. Sacrificial, there is a small difference in the sacrificial protection method and the cathodic protection method. That in the sacrificial protection method, no power source is being applied, whereas in the cathodic protection method, external power source is applied. This method can be used in the absence of powers. Initial cost of this method is found to be very low as compared to the other method. Simple installation is there, less supervision, and additional anodes can easily be replaced and added when the anode is completely consumed. So basically, sacrificial protection method is basically used to protect the ships which are basically immersed in lot of water area, water heaters, pipelines, underground and above ground tanks, refineries, etc. So this method is found out to be very useful to those metals which come in direct contact to the water or present in the water area only. So this is all about. These are the sacrificial anode for tubular steel pipes. Here we can say anode portion is taken. Here we can say this is white electrode is there. That is the more reactive metal, and the steel piles are there, which acts as cathode. And these metals are being protected because of the presence of more reactive metal taken as anode. So this is all about for today's session, as I have crossed the timeline already. Mr. Himal. Any other questions?
Yes, ma'am. Ma'am, there is one question.
Yes.
Am I audible?
Yes.
Generally, corrosion occurs when metal is in contact with air or moisture. Okay.
Yes.
So, can corrosion occur without oxygen?
Not exactly. Without corrosion also takes place. If the metal reacts with the sulfur dioxide, carbon dioxide, I have talked about it in the particular factors affecting. If we convert the pH range and the particular metal is susceptible to react with the sulfur dioxide or the carbon dioxide react and the moisture also, then also the metal corroded.
Okay, thank you.
Thank you.
Yes, okay. Thank you so
Is there
much,
any
ma'am,
other question?
for joining with. No, ma'am.
Okay. Thank you so much.
Yes, thank you so much, ma'am, for joining with us today and giving us your valuable time. I'm sure this session would help to our students. And I also thank to our head of our department, Mr. Hemal Patel sir, head of our institute, Dr. Jatin Vaidya sir, and the president of our university, Dr. Devanshu Patel sir, for supporting and motivating us continuously in conducting such webinars. Thank you so much, madam. Okay, bye.